Right, so I'm going to present the work which we have done, actually not on the Consul project which you have just seen. Instead, we are going to actually work on user stance prediction from Twitter data. Okay. Right, so first, what is the stance detection? So usually stance detection is just try to understand whether user will support or kind of oppose a certain kind of a topic. One kind of a data we use here is the Twitter data. So from the Twitter data, we know that we would be able to extract the so-called users posting behaviors. So you can imagine you could extract the users tweet timeline, right? And then from the Twitter data, we can also extract the user social networks structure. And from the user social network structure, we will be able to identify the social influence among different users. So from both the content, the text data and social network data, we will be able to detect the public opinions. And then it can be used in a wide range of applications, including like politics or including the market analysis. So we have collected two set of Twitter data. One is the tweets from the Brexit, but then that's back in 2016. So we use some predefined list of hashtags and to collect the relevant tweets. And then afterwards, we actually split this kind of a tweet stream into different time periods. Right? So we want to see how user stance change over time. And we also collect the tweets relating to US general election also in the same year, and then using some of the keywords relating to the US general election. So the statistic of data is shown in this figure here. So essentially, we kind of basically using some machine learning model, actually like a train on large scale of distance supervised data to actually detect the stance. So we have three stance labels, either oppose, neutral, or support. So in the Brexit data, support meaning like whether this person would actually support Brexit, or the person actually would go against Brexit, and whether the user actually just hold a neutral opinion towards Brexit. Right. So we basically have a different color to indicate the number of tweets relating to different stance label. So we can see that on the Brexit data, we have a kind of a more or less balance of a stance distribution. But then on the US general election data, we actually have a kind of imbalanced data, right? Because we will see most of the tweets actually relating to support Trump. Okay. Right, so the first thing we want to do is we would like to discover the users' viewpoints behind their stance. So, rather than simply classifying if the tweet is a support or oppose a particular kind of a topic, we want to understand the users' reasons behind. And oftentimes, those reasons actually form this hierarchical structure. So one example is illustrated by this figure. So suppose the topic we are interested in is this Trump actually run for president of the U.S. And some people actually want to support Trump, and then some people actually oppose Trump. But then we want to understand what's the reason behind. So underneath the support stance, we might be able to identify the topics relating to economic policy, right? And then under which we would be able to perhaps identify more fine-grained topics. So one example you can see, if there's a tweet, perhaps that would relating to this personal charisma. And then there's also another tweet actually relating to racism. So basically people support or oppose Trump for different reasons. And then that's the kind of goal we want to do. So we want to design a model which will be able to automatically discover this hierarchical viewpoint structure from Twitter data. So the model we propose is called this hierarchical opinion phrase model. It's actually modified upon this so-called hierarchical latent dirichlet allocation model. So that's just a kind of a unsupervised hierarchical model, which will be able to detect the so-called hierarchical topics from text data. But then we have a number of modifications. So the first thing we did is we place a root topic, and assuming this topic will be captured all the common words used by people holding different stance or holding different opinions. And then afterwards, we actually try to split the people's tweets into two groups, right? So the one group would be people actually support particular topic. Another group would be people oppose that particular topic. So the benefit of doing this kind of a binary split of these tweets into two groups is actually allowing us to impose some kind of a prior sentiment information or prior stance information into the model. And we will come to this later. Right, so the last modification we did is instead of this so-called backwards assumption in the original hierarchical topic model, which means they ignore the word order. So basically they just care about the word occurrence or not, and then rather than considering the specific occurrence order of the word sequence. So here we actually have some mechanism trying to capture the generation of the phrases conditional on some specific topic. I'll just show you the one example kind of a hierarchical topic structure we discover from this Brexit data. So on this Brexit data, the root topic is that, as we said earlier on, so it just covers some common words appear in both sort of group of tweets, either support or against Brexit. Now the level 2 topic supposed to to some kind of relating to this binary split, right? Either support or against. It might not be apparent from the words occurred under this topic whether that's actually expressed the support stance or against stance. However, we can actually look into the topics in the deeper level of this particular branch. And actually, you would have a better idea, So those topics, they are kind of indeed relating to support. So for example, you see the topic relating to immigration, right? So people actually they support Brexit because they think, UK would have a better immigration control. And also, there's a topic relating to NHS public services. So that's, kind of another reason why people support Brexit. And in terms of this against Brexit, so, that might be people have a sort of concern over the human rights. And then also there's a event relating to the murder of this Joe Cox, right? So that's some other topics we identify under this against stance. Now on the U.S. general election data, so the stance here is whether the people actually support Trump or against Trump. So against Trump usually means they actually support Hillary. So again, we can see the list of more fine-grained topics or hierarchical topics under these two different stances. And interestingly, we can also identify these important phrases highlighted in red color. So they're sort of relevant to a specific kind of hierarchical topic here. Right, so that's kind of hierarchical viewpoints we will be able to discover from the Twitter data. Now the next thing what we did is using our proposed model, whether we would be able to perform this stance classification. So sort of just to classify a tweet, whether the tweet holding the support stance or against the stance. We actually divided the model into two groups. So the first half, we have this so-called unsupervised model. So the model trained without using any so-called label information. So there's no stance class label information to train this model. And we can see that basically the model performed quite poorly, right? So that's actually expected because without the supervised information, then it's hard to train the model to be able to do this stance classification. But then our model, so this is our proposed hierarchical opinion phrase model, still outperform the other baselines. Now, the right kind of group models, so they have some kind of supervised information injected into the model. So in specific for our model, what we did is, if you still remember, in the level 2, so in the previous kind of like hierarchical topic structure, right? The level 2 actually like, we hope the level 2 topic would denote the support or against kind of stance. So what we can do here is we can use those hashtags. So some tweets comes with a hashtag, actually like indicative of a user's stance, right? So you will see like in the general election tweets, maybe the people will add the hashtag like a vote Trump, right? So that would be like indicating this user actually support Trump. So we make use those information to put in this kind of like a prior stance label knowledge into the model. And you can see that we are able to bring this classification accuracy much higher compared to this unsupervised counterpart, right? So that's in a bit of part which we do this hierarchical viewpoint extraction from the Twitter data. And in another piece of work, actually, we want to predict the user stance dynamics, because we think the user's opinion stance, they are not fixed. They might change over time, especially like, they might receive the kind of influence from their friends, right? So one example here is you can see if the user has this social circle or social networks, and then basically depending on, what their, sort of like a friend's opinions towards some subject matter, now the user's kind of, opinion might change, right? So that's kind of like, rationale behind our proposal of this particular model, which we assume the users might be influenced by the friends. And also, often like his friends could post tweets on wide variety of topics, right? But users, sort of like only pay high attention to those topics which they are interested in. And the last thing is a user's opinion is actually kind of a combination of their own, sort of like their own sort of like past tweets post on that particular topic, and also the influence from their social friends, right? So we propose this as so-called neural opinion dynamics model. We assume the tweets actually like come in this temporal order, and we can order these tweets into different time windows. And we try to leverage both the content information, so the text information, and also the context information. So the content information come from the user's friends, so the tweets posted by their social circle. And in each epoch, so when the user posts a sequence of tweets, we assume each tweet can be represented by some embeddings. So it's just a kind of a continuous vector representation. And in addition, the user's opinion will be influenced by their neighbors or their friends, okay? Right, so this is kind of like a problem set up. In the top level, so we have tweets coming, so organized into different time windows. So each sort of like a box here just denote the set of tweets in that particular time period, okay? And if we zoom in into this particular epoch, so that will consist of a user's posting sequence, right? So for different users, they might post a sequence of tweets during this time period. And then each tweet here basically would be represented by both users' content, the tweet content, and also the tweets posted by their friends or by their neighbors in their social network. So we have this kind of a neural network architecture to model this information. So in essence, what we did is here, first thing is we need to represent the topic expressed on the user tweet. So for that, we need to extract these hierarchical topics as I just described from the Twitter data. And then we can convert these topics into some continuous vector representation. So we call it topic embedding. And then, so when users post a tweet, they should pay higher attention to their neighbors' tweets which share similar topic, right? So which like, post a topic which the user has a particular interest in that, kind of subject matter. So at the end, each tweet actually, the representation is a combination of this both the content representation and also the topic representation, right? And the next thing, we need to actually measure the degree of influence from the user neighbor, because like the user might pay high attention to this friend, but then lower attention to another friend, right? So we need to have some way to judge that difference. So the final kind of this so-called tweet representation is actually this weighted combination of both the user's current tweet content and also their neighbor's tweets. Okay. So after we have have some mechanism to take into account the user's neighborhood contextual information and also user's tweet content information, then we can actually fit the user's posting tweet sequence into this so-called gated recurrent unit. I mean, it's just kind of a recurrent neural network, which will be able to deal with this kind of time sequence information to do the prediction. So now our training objective is try to minimize the KL divergence. So KL divergence is, you can imagine it as the measurement of the similarity between two distributions, probability distributions, right? So we have the predicted distributions of the user stance over a range of different topics, and then versus the actual stance distribution over the list of topics, and then we can measure the difference between these two. Alternatively, we can also perform this so-called cost level stance classification. So instead of trying to predict the user stance towards a specific topic, we can actually just have this three-class classification, right? So basically, like given the user's tweet posted in the past, we want to predict the user's sort of like in the future stance, whether the user is opposed, neutral, or support, but then without considering any specific topic. Okay. So in this, in the latter case, we use another objective function. So that's a so-called cross-entropy loss. So basically, it's just to measure the similarity between the class prediction results. Okay. So in terms of experimental setup, we basically it's difficult to acquire the ground truth stance label. So what we did is we used this distance supervision. So basically, we just make use of those hashtags indicative of a clear stance of the user's opinion, and then use those hashtags as a proxy label, stance label, to train a supervised classification model. So that will give us some kind of a stance label for the tweets. And we actually compare with some other methods based on the sentiment lexicon. So the sentiment lexicon contains a list of words, either like positive or negative polarity, right? And we actually find out, our kind of model trained on large scale of weakly supervised data perform much better than the other lexicon-based approach. And we compare our model with a list of a range of baselines. So you can ignore these baselines, but then you just need to see the results. So the results actually, we show the both classification, stance classification accuracy, and also the F1 measure. Or in comparison with a range of different models on the Brexit data. So basically the top line is our model. So it just performs the best compared to all the other models. And similarly on the US general election, okay? But then what's more interesting here is we can actually check the user stance dynamics. So in this figure, we actually show the aggregated user opinion on the Brexit data. And here we only show 3 topics here, right? So the bottom, this red line would be the topic relating to economy. And then this dash yellow line would represent this Boris and Farish, so that particular topic. And then this green line represents the topic relating to immigration. And then this y-axis actually show this aggregator sentiment score. So 0 means neutral, right? So basically user neither support or against, but then positive score meaning the user actually support Brexit, and negative score meaning the user actually against Brexit. So we can see that the overall stance for economy actually is more towards opposing right? So it's actually this red line here, more towards the opposing, so indicating like people generally felt the Brexit would affect the economy negatively. And then overall, this sort of like stance for immigration is, however, positive. And with more people actually switch to the positive towards the the end of this this time period. So this axis actually is indicating the time period. So the left figure is just the aggregated kind of a user stance, and the right figure here we have this individual. So we look into user A, so just one particular user, and to see how this user A's stance change over the time. So for user A, we can actually see that user A change her views more dramatically, right? Because this user actually started with negative views on all these three topics, but then eventually actually switched to more positive view towards the end of this time period 8. Okay, so that's right. So that's actually the end of my talk, right? So we basically like have models try to understand users' opinions expressed online, and they also has a model try to predict the user stance dynamics. We do have some kind of like a future work intend to investigate. So for example, here we only consider the user's social network based on this following relations. We could also construct the user social network using other retweeting or mentioning relations. And the other thing is we didn't actually consider the neighbor's influence score, right? Because some user might have a higher influence score compared to the others. And the other thing here is we in this neural opinion dynamics model, we actually separating the topic discovery versus this stance dynamics prediction in this pipeline approach, right? So in the future, we intend to investigate unified model to combine these two tasks together. Okay, so that's the end of my talk. Thank you.